Good morning students. Now it is second year mathematics and we are doing application of derivative. Chapter 6 we have started. Already we have done chapter exercise 6.1 and also 6.2 I think we have finished up to question number uh, up to question number 13 finished. Now I think today we have to do question number 15. So let's start. Let I be any interval disjoint from -1 to 1. Disjoint from -1 to 1 means that is other than -1 to 1. That is in between -1 and 1. So many points are there. Suppose -0.5, -0.6, -1.1, 0, 0.1, 0.2, 0.3, 0.9, then 1. Then these whole numbers you cannot take. Other than these numbers, these real numbers, you have to take other parts of real. Prove that the function f given by fx equal to x plus 1 by x is strictly increasing in I. So strictly increasing on I. That we have to prove. We have to do. So question number exercise 6.2, question number 15. See here, fx is given as what? X plus 1 by x. As it is application of derivative, definitely we have to do what? Differentiate. If we differentiate, then differentiation of x is 1 and differentiation of 1 by x is minus 1 by x square. So this is nothing. This you see that this is we can do. Now we can take the LCM. If we take the LCM, it will be x square minus 1. Then, now you see, then is it what? Positive or negative for any value other than -1 to 1? So, for real number minus open interval -1 to 1. If we take f dash x, it is what? Other than -1 to 1 means what? If it is less than -1, suppose -2, if you put here, then it is 4 minus 1 by 4. 2 square give 4, 4 minus 1 to 3. And 2 square that is 4, 3 by 4. It is a positive number. And if we put what? Greater than 1, that is if we put 2, then we get this. If we put -2, this one. What it indicates? That for every value other than, every real number other than -1 to 1, we get a positive things. So as we get positive, from theorem we can say, therefore fx is increasing in given increasing function in given interval. So this is our question number 15. So this I think you understood these things. Now we will do question number 16. So here application of derivative and it is increasing decreasing function. So we are able to do question number 15. Question number 16. Here they say prove that the function f given by fx equal to log sin x is strictly increasing on 0 to 90 and strictly decreasing on 90 to 180. So see here, it's strictly increasing in one interval and you have to prove it is strictly decreasing on other interval. So here fx is given as log sin x. This is our fx. So this it is given. And we have to do what? Find the first derivative. As it is application of derivative, of course. Log of sin x, log of any function's derivative is reciprocal of it. So it is 1 by sin x. Then differentiation of again sin x we have to do, and it is what? Cos x. It is the rule that we have to use chain rule. Chain rule said that whatever it is, use the log differentiation and then you differentiate again that cos x. So we get what? Cot of x. Now we have to you check that within that interval what it is. So for 0 to 90, if you consider this interval, f dash x, that is cot x. If we take 0 to 90 any value, then cot x is always positive. That we have this one, so it is greater than 0. And if we consider this 90 to 180, f dash x. Now see, if you greater than 90 to 180, if you take any value, suppose 120, then you will get what? Suppose 120, 90 plus 30. Then cot 90 plus 30, it is what? Cot 120 degree. How to calculate? Cot 90 plus 30. Then cot 90, it will becomes 10, 30. And second quadrant, cot negative. Cot 10, 30 is 1 by 50. So what value we are getting? Negative. Not only for this, any value, if we take in between 90 to 180, it gives a negative value. So what we can say, that is, in this interval, as f dash x is positive, so it is what? Fx is increasing in that function. As we get for this interval, f dash x is negative, so what we can say? Say fx is decreasing for the interval 90 to 180. So hence nothing. So we are able to prove what they have asked. Yes, that we have done. So this is our question number 16. Okay, I think you understood these things. Now we will do question number 17. Prove that the function fx is equal to log cos x is strictly decreasing in 0 to 90 and strictly increasing on 90 to 180. It is similar thing, so it is your homework. So question number 17 you have to do, and it is as homework. So you will do question number 17 as homework. So this is homework, one homework I have given today. Now question number 18. Prove that the function given by fx equal to x cube minus thrice x square plus thrice x minus 10 is increasing on r. So here they have said you have to prove another thing. Here interval is given as real number and fx is given as a cubic polynomial. So you have to prove that it is a increasing function in every real number. So how to do? Question number 18. fx is given as x cube minus 3x square plus thrice x minus 100. Now if we differentiate, then it is 3x square. If we differentiate this one, 3 is constant, x square differentiation is twice x, so it is 6x. If we differentiate this one, it will be only 3. So this is the differentiation of this term. Now if we take 3 common, x square minus twice x plus 1, then we can write x minus 1 whole thing square. Now see, x minus 1 whole thing square, if you put any value of real number x, then as it is a square term, so what it can be? It is always positive. So you can say this is a which is a what? Perfect square, so it is always greater than 0. Its least value is 0. So you can say as it is greater than 0, positive only, therefore that we can say it is only increasing on this real number. So hence the proof. So we are able to find that this function without putting that values and all these things, just watching that it is square is given, so it is a increasing function. Right. Now we will do question number 19. Question number 19, they say the interval y is equal to x square e to the power minus x is increasing with respect to x is. It is 19, y, instead of giving x, they have given y. So this value, this function they have given y is equal to x square minus x square into e to the power minus x, and it is increasing in x in which interval, whether it is first option given minus 1 infinity to infinity, or minus 2 to 0, or 2 to infinity, or 0 to which interval it is working. So dy dx, you will find it is what? If we differentiate, it is the u into v form. If we differentiate x square, it will give twice x. E to the power minus x will remain same. X square. If we differentiate e to the power minus x, it will be minus e to the power minus x. Chain rule all we have to apply for this one. So we get differentiation of this one is this. Now we can take x common and e to the power minus x common. 2 minus x. So this is our differentiation of this one. So what can we say about these things? That if we differentiate these things, then we get this one. Now we check that so many options are given. If we put any positive number, then it is positive. If we put any number in x, e to the power positive or negative, it will give what? A positive things. Only we have to take care that if we put any values that is greater than 0 and less than 2, it will give a positive term. I again want to repeat, so many intervals are given. Out of these so many intervals, if we put x in between 0 to 2, in between 0 to 2, then only we get this one is positive. 0 to 2, a positive one, 0 to 2. For that interval, this is positive, any value if we take, suppose in between 0 to 2, 1 is there, 2 minus 1, it is also positive. So this gives a positive, so option D you can say, but 2 to infinity you cannot take, because if you put here greater than any value than 2, suppose 3, this will give negative, but this is positive, it will be what? Negative 1. If we put minus 2 to 0, in between this minus 2 to 0, suppose minus 1. If we put here, this is minus 1, and so as we have only what? Minus 2 to 0, minus 1, so this is minus 1, this is positive, it is again negative. If we put minus infinity to infinity, all values minus infinity to infinity will not give the positive. So for x belongs to 0 to 2, dy dx, it is what? A positive term is greater than 0. Therefore, correct option, the answer, it will be what? Option D only. So we can say this is the correct way, as we found that this is the things. Now we will move for our next exercise. Next exercise, that is 6.3. There you will find that tangent and normals of a given curve. Suppose this is a curve. This is axis or axis. At that point, P, x1, y1. If we draw a line which just touches the curve at a single point, it just touches the curve at a single point, this is called tangent. And at that point, if we draw a line which is perpendicular to the tangent, this is called normal. I again want to repeat, a straight line which just touches the curve at a single point, it is called tangent. a straight line at that point which is perpendicular to the tangent, it is called normal. Now what is the formula for tangent? Equation of tangent at the point x1, y1, it will be y minus y1 dy dx x minus x1. I think only one formula is sufficient to do all the sum. And for another normal, it will be y minus y1 minus 1 by dy dx x minus x1. Now you see, what is the difference? Here dy dx, here minus 1 by dy dx. That two only things. I found so many books, so many persons giving so many formulas. Not required. You just follow only one, these two formulas, then you can do total exercise 6.3. Now 6.3, first sum we are going to do. Here they have said, find the slope of the tangent to the curve y is equal to 3x to the power 4 minus 4x at x equal to 4. So what they have given, y is 3x to the power 4 minus 4x. And what they said, slope of the tangent you have to find. Here in this equation, this is slope of the tangent. This is slope of the normal. This is what? Slope. That one is also slope. First one is what? Slope of tangent, and minus 1 by dy dx, it is slope of normal. So we have to find what? Just dy dx. If we differentiate y with respect to x, it will be, see here, 3 is constant, it will remain outside. 4x to the power 4, its differentiation is 4x cubed. So it will be what? 12x cubed. Now, next they have said what? That minus 4x. So if we differentiate 4x, 4 will remain same and x is differentiation is 1. Now we have to put the point. They have said one point is given, that is only x coordinate of that point is given at x equal to 4. For that point, dy dx, that is slope, it will be what? 12 into 4 cube minus 4. And after simplification, 4 cube is 64, 12 into 64 is what? 768. 768 minus 4, it is 764. So what is the slope of the tangent at that point? I think we get what answer? That it is 764. So students, this is, that thing is what? Tangent, equation of tangent and normal. So I expect that you understood this sum, and it is not so complicated. It is what we have to do. For you have to remember, equation of tangent is y minus y1 dy dx, and remember dy dx at the point x1 y1, you have to find the value and then into x minus 1. For equation of normal, y minus y1 minus 1 by dy dx, and you have to put the value of this one for x1 y1. This is the equation of normal. This one is dy dx for the value x1 y1. It is what? Slope of tangent, and minus 1 by dy dx at x1 y1, it is slope of normal. Then in first sum, what they said, it is just a simple one, that they said you have to find the value of slope of the tangent at that point, and simply you have to do the differentiation, and after differentiation you have to put the value of that given value of x equal to 4. So this will give your slope of tangent. So we will do next sums, next onward sums of 6.3 in next classes. So with that we end our today's class.